Hi, this is Sailaja. I'm the mentor for chemical science of CSIR Net. In this particular video, I'm going to discuss about the whisper theory and details about the whisper theory. Whisper stands for valence shell electron pair repulsion. This theory is used to predict the shapes of molecules geometrically. So if have any questions about how the pairs of electrons arranged around the central atom, so whisper theory is the solution for that. The table shows that the pairs of electrons arrange around a central atom and the steric number also given in the table. Steric number is the number of atoms and lone pairs bonded to the central atom of a molecule. If a steric number is 2 and lone pair is 0, then it is the geometric is the linear shape. If a steric number is 3 and lone pair is 0 and it is a trigonal planar, like that, based upon the steric number and the number of lone pairs, the geometry information can be predicted about the molecule. So we can understand what is the geometry shape from this particular slide. Here geometry details provided. If it is a linear, predicted bond angle is 180. If it is a triangular planar, predicted bond angle 120. Tetrahedral shape, then 109.5 degree. Trigonal bipyramidal, in this case 90 degree and 120 degree. Octahedral, if it is a geometry, then the bond angle is the 90 degree. This we can understand with examples from the next slide. This is the slide is about the molecule BEF2, and there are only two places in the valence shell of the central atom in BEF2 where electrons can be found. The repulsion between these pairs of electrons can be minimized by arranging them so that they point in opposite directions. That is the reason the whisper theory predicts the BEF2 should be a linear molecule with a 180 degree angle between the two BEF bonds. So this is one BEF bond and this is another BEF bond. This is one bond, this is another bond. So between these two 180 degree, that is the reason of it is a linear. And next example for the trigonal planar. There are three places on the central atom in boron trifluoride BF3 where valence electrons can be found. Repulsion between these electrons can be minimized by arranging them toward the corners of a equilateral triangle. The whisper theory therefore predicts a triangle planar geometry for the boron trifluoride molecule. This is a bond angle between fluorine, boron and fluorine is the 120 degree. This is the 120 degree. That is the reason of triangular planar. So here, this is 120. It's 120 degree. Next example for tetrahedral. Tetrahedral will take an example BF2 and BF3 are both two-dimensional molecules, what we discussed previously. If we place same restriction on methane, we would get a square planar geometry in which the hydrogen, carbon, and hydrogen bond angle is 90 degrees. If we let this system expand into 3 dimensions, however, we end up with a tetrahedral molecule in which hydrogen, carbon, and hydrogen bond angle is 109 degree, 109.28 degree. So that geometrically looks like this. Next, trigonal bipyramid. Repulsion between the 5 pairs of valence electrons on the phosphorus atom in F5 can be minimized by distributing these electrons toward the corners of the trigonal bipyramid. 3 of the positions in a trigonal bipyramid are labeled equatorial because they lie along the equator of the molecule. The other 2 are axial because they lie along a axis perpendicular to the equatorial plane. The angle between the 3 equatorial positions is 120 degree, while the angle between an axial and equatorial position is 90 degree. And next, octahedral. There are 6 places on the central atom is SF6 in SF6 where valence electrons can be found. The repulsion between these electrons can be minimized by distributing them toward the corners of a octahedron. The term octahedron literally means 8 sides, but it is the 6 corners or vertices that interest us. To imagine the geometry of an SF6 molecule, look at fluorine atoms on opposite sides of the sulfur atom along X axis, Y axis, and Z axis of an XYZ coordinate system. So in this way, you can understand this octahedral. That is the end of VSEPR explanation in this particular video. I will give you another details, another topic in the next video. Thank you.